Hey, geometry. So we're going to get into the a couple of our laws. We have our laws of detachment and our law of syllogism. Let's start off with the law of detachment. So if the hypothesis of a conditional is true, assuming the conditional statement is true, but if the hypothesis of a conditional is true, then the conclusion needs to be true. So in symbols, if P then Q, if P then Q is true, and P is true, then we conclude that Q is true. So let's look at an example. Given, if a car is out of gas, then it will not start. And then they're going to tell us Sarah's car is out of gas. So we know the hypothesis is true. Then, given that this statement is true, this conditional statement is true, we can conclude the conclusion is true. So it will not start. And specifically, we could say here, Sarah's car will not start. And that is a logical conclusion we can make using the law of detachment. We know the hypothesis is true, so we can conclude that the conclusion is true. And so then using that again, if the student gets an A on their final exam, then the student will pass the course. Felicia gets an A on her geometry exam, and let's make sure we make it clear that that is a final. If it's not a final, we actually can't conclude anything, but we'll say it's our final exam. So if she concludes her final exam, then Felicia will pass, and specifically the geometry course. So that's our conclusion with that law of detachment. Our next one, if ray divides an angle into two congruent angles, then the ray is an angle bisector. So if a ray divides it. RS divides angle ARB so that ARS is congruent to SRB. That lines up. This ray is dividing an angle into two congruent angles. So we conclude that ray RS is an angle bisector. And then finally, if two angles are adjacent, then they share a common vertex. So we know if this is true, then that is true. We're told that angles 1 and angle 2 share a common vertex. So we're told the conclusion is true. But we can't conclude that the angles are adjacent. If we were told the hypothesis, we could conclude this. But this isn't like an if and only if. We can't go in the other direction. It's not a biconditional. So angle 1 and angle 2 share a common vertex. That doesn't necessarily mean they're adjacent angles. They could be vertical angles, or they could be something else. So we actually can draw no conclusion from this. The rest were telling us that our hypothesis is true, so we could conclude that our conclusion is true. This one doesn't tell us our hypothesis is true. It tells us our conclusion is true. We can't draw anything about the hypothesis based on that. So that's the law of detachment. The law of syllogism is a bit different, but it's also we can draw these logical conclusions for conditional statements. So the way this one works is if P is true, so if P then Q, if that's true, and if Q then R is true, then what we can draw is if P, like we can kind of make that logical step. This is kind of similar to the transitive property. So this is like the transitive property. But it's kind of for logic for conditional statements. If P is true, then Q is true. And if Q is true, then R is true. That means if P is true, then R is true. We can kind of leave that Q out. So if it is July, then you are on summer vacation. So we'll say, I'm just going to underline this. And so that's our conclusion. If you are on summer vacation, then you work at an ice cream shop. And so what we can kind of do is we can put this all together. If it is July, then then this will be true. And then if that's true, then this is true. We can go straight to this. From if it's July, then you will work in an ice cream shop. We're going to kind of bunch it together, and we can kind of take out that middleman there, and so we can draw that conclusion. And it's assuming both of these statements are true. I'm assuming not all of you work in an ice cream shop, but for this individual, whatever it is, true. So if it is July, then you work at an ice cream shop. Ice cream shop. All right, so what can we conclude based on the given information? If a figure is a square, then the figure is a rectangle. If a figure is a rectangle, so we're going to, the figure is a rectangle, I'm going to kind of do this similar pattern. If the figure is a rectangle, then the figure has 4 sides. Well, we can conclude if the figure is a square, then the figure has 4 sides. Because squares are rectangles and rectangles have 4 sides. Then the figure has 4 sides. The next one, if you do gymnastics, then you are flexible. If you do ballet, then you are flexible. So you might want to try and put those together somehow, but this one doesn't work. If you do gymnastics, then you are flexible, but this also says you're flexible. It's not if you were flexible, then you do ballet. Then we could do something about this. But no, we actually can't draw the syllogism conclusion from this. We need our conclusion. You know, if then we have our conclusion from one is our hypothesis from the other, then we can combine them into one statement. This one, we have no conclusion. All right, so using the laws of syllogism and detachment, what can you conclude from the given information? We can kind of put these all together, and this gets kind of messy, and you know, we could do it in other steps. But if you leave your car lights on overnight, then your battery will drain. And then we have if your battery will drain. So we see this, your battery will drain, conclusion matching this, your battery will drain, hypothesis. If your battery is drained, your car may not start. So we could conclude from this to this. We conclude if you leave your car lights on, and then you know your car may not start, or overnight or whatever. I could circle that as well. So we could kind of put those two together, and that is syllogism. But then we also have this, Alex left his car lights on last night. So he left his car lights on last night, so that's using the law of detachment with kind of this combined statement. We can conclude that his car may not start, and that's kind of where we can get to with this. Alex's car may not car may not start. A little better. That's what we can conclude using a little bit of both. A little bit of law of detachment, knowing this fact, knowing this is a hypothesis, we can draw that conclusion, and we put those two together using syllogism. Next one, if a river is more than 4,000 miles long, then it is longer than the Amazon. If a river is longer than the Amazon, so we kind of see here we have our conclusion and our hypothesis there. If it's longer than the Amazon, then it is the longest river in the world. So we can put those together. If a river is 4,000 miles long, then it is the longest river in the world. And then finally we have the Nile is 4,132 miles long. So that fact is true here. So that means that this hypothesis is true. So we can draw this conclusion about the Nile. The Nile is more than 4,000 miles long. So the Nile River is the longest river in the world. So ultimately, we combined those two together using syllogism, or syllogism there, and then we use this fact in conjunction with that, using the law of detachment to draw the final conclusion that we're dealing with the longest river in the world. Another way you could approach this, you could go law of detachment right away and plug it into this one. Say the Nile River is more than 4,000 miles long, so the Nile River is longer than the Amazon, and then we know the Nile River is longer than the Amazon. We could actually go detachment twice on this. So then we know the Nile River is the longest river in the world. We could kind of show that this, because this hypothesis is true, that conclusion is true, because then that conclusion tells us this hypothesis is true, then that conclusion is true. But different ways we can use those laws to logically make an argument.